Hello, this is Byron from Mr. Cherry's Blue 2 class for AP Calc VC. And for our group project, the sum that I'm going to do is actually a Riemann sum to basically find the integral under RT from 0 to 12. And we're going to be using the data points from this table right here in order to do that Riemann sum. So for a Riemann sum, you take the base, which for the first base, it's going to be 2 minus 0, which is just 2, and then times the height on the right, which is 4, since we're doing a Riemann sum. If it was a left Riemann sum, we'd actually be using 5.7, but since we're doing Riemann sum, we're starting from the right side. And so that's our first one, 2 and 4. And then for the next one, same thing, 5 minus 2 is our base, which is 3, and times our height on the right, which is 2. And for the third point that we're using, it's 2 for the base because it's 7 minus 5, and then times 1.2 for the height, and then 11 minus 7, same thing here for 4, and then times 0.6 for the height, and then 12 minus 11 for the base for the last one, and then times 0.5 because that's the height. And for the Riemann sum, all you need to do once you get there is just add them all up, and you will have the integral. And so 19.3 feet right there is actually the answer for the Riemann sum of the integral r prime of t from 0 to 12. Now r prime of t from 0 to 12, when t is in minutes and r prime of t is in feet per second squared, that actually has a meaning. It would be the change in radius from t equals 0 to t equals 12. So for example, the radius at the start changed 19.3 feet from the beginning to end. So that's what this number actually means realistically when you put it into play, I guess. So that's the right Riemann sum right there. If you're doing the left Riemann sum, it would be the same thing, just using starting with 5.7 for height instead of 4, and that would be the answer for that. Thank you.